Nuclear bombs have shaped the course of history with their unimaginable power. Did you know the largest ever detonated was over 3,000 times more powerful than the bomb dropped on Hiroshima? These weapons aren't just relics of the past. They remain a critical part of global security and military strategy today. The question is, how well do you really know the most powerful nuclear bombs ever created? Let's dive into the top 10 that changed the world forever. Tsar Bomba, Soviet Union. Tsar Bomba isn't just another nuclear weapon, it's the absolute titan of atomic destruction. Tested by the Soviet Union back in 1961, this bomb unleashed an explosion so massive, it remains the largest nuclear detonation in history. With an estimated yield of 50 megatons, the Tsar Bomba was over 3,000 times more powerful than the bomb dropped on Hiroshima. Its shockwaves circled the Earth multiple times, and the blast was visible from hundreds of miles away. The sheer force of this bomb was so overwhelming that it shattered windows up to 560 miles from the test site, and the mushroom cloud soared 40 miles high, far beyond the cruising altitude of commercial airplanes. Designed primarily as a show of power during the Cold War, the Tsar Bomba wasn't intended for practical military use. It was a statement, a terrifying demonstration of Soviet technological might. Engineers actually reduced its original 100 megaton design to 50 megatons to limit fallout, but even then, the bomb's destructive capacity was unprecedented. The test raised serious questions about nuclear proliferation and the terrifying potential of human-made weapons. Despite its enormous power, the Tsar Bomba was never deployed in combat, but its legacy still looms large as a symbol of the Cold War's nuclear arms race and the devastating consequences of unchecked weapon development. Understanding the Tsar Bomba is crucial to grasping the scale of nuclear weapons and the importance of global disarmament efforts today. B-41 United States. When it comes to raw destructive power, the B-41 nuclear bomb was the United States heavyweight champion during the Cold War. With a staggering yield of up to 25 megatons, the B-41 was the most powerful thermonuclear bomb ever deployed by the US military. Imagine a bomb so powerful that its explosion could level entire cities in a single blast. Developed in the early 1960s, the B-41 was designed to counter the growing nuclear threat from the Soviet Union, serving as a key element of America's strategic deterrent. Its immense power came from a three-stage thermonuclear design, which allowed it to unleash more energy than most other bombs in the US arsenal. Despite its terrifying strength, the B-41 was relatively compact for its yield, making it easier to deliver via long-range bombers. However, its sheer size and power also meant it was incredibly complex and expensive to produce. The bomb was retired in the early 1970s, replaced by more advanced and versatile warheads, but its legacy remains as a symbol of Cold War brinkmanship and the nuclear arms race. The B-41's existence highlights the lengths nations went to during that era to maintain a balance of power through overwhelming force. Understanding the B-41 helps us appreciate the scale of nuclear weapons development and the ongoing importance of arms control in preventing such devastating power from ever being used again. Castle Bravo, United States. The Castle Bravo test is one of the most infamous moments in nuclear history, not just for its power, but for its unexpected consequences. Detonated by the United States in 1954, Castle Bravo was the first dry-fuel thermonuclear bomb ever tested, boasting a yield of 15 megatons, more than double what scientists had predicted. This massive miscalculation led to widespread radioactive fallout that contaminated nearby islands and exposed thousands of people to dangerous radiation. The explosion was so powerful that it vaporized an entire island and created a mushroom cloud over 25 miles high. Castle Bravo became a stark reminder of the unpredictable and devastating nature of nuclear weapons, highlighting the risks of testing and the long-lasting environmental and human damage they can cause. Beyond its destructive force, the test also intensified global fears during the Cold War, fueling the arms race between the United States and the Soviet Union. The incident pushed governments to reconsider safety protocols and the ethics of nuclear testing, marking a turning point in how the world viewed atomic weapons. Despite its tragic fallout, Castle Bravo proved the effectiveness of dry-fuel hydrogen bombs, paving the way for more advanced thermonuclear designs. It remains a powerful example of how nuclear technology can spiral beyond control, underscoring the importance of caution and responsibility in handling such immense power. This event still echoes today in discussions about nuclear safety and disarmament, reminding us that even the most powerful weapons come with unforeseen and far-reaching consequences. RDS-37, Soviet Union. The RDS-37 marked a major leap forward for the Soviet Union in the nuclear arms race, becoming their first successful two-stage hydrogen bomb test in 1955. This bomb wasn't just powerful, it was a game-changer, with a yield of 1.6 megatons that demonstrated the USSR's ability to develop thermonuclear weapons rivaling those of the United States. Unlike earlier atomic bombs that relied solely on fission, the RDS-37 used fusion, releasing exponentially more energy and setting a new standard for destructive capability. The test was conducted in Kazakhstan, and the blast was so intense that it shattered windows over 100 miles away and produced a mushroom cloud that soared miles into the atmosphere. This breakthrough sent a clear message during the Cold War. The Soviet Union was no longer behind in nuclear technology. The RDS-37's success accelerated the arms race, pushing both superpowers to develop even more powerful and sophisticated weapons. Yet beyond its military significance, the test also raised awareness about the catastrophic environmental and human costs of nuclear detonations. The RDS-37 remains a symbol of Cold War tension but also a reminder of the terrifying power humanity unlocked in the mid-20th century. Its legacy is a crucial chapter in understanding how nuclear weapons evolved and why global efforts toward arms control and disarmament remain so vital today. B-53, United States. The B-53 nuclear bomb was one of the most fearsome weapons ever built by the United States, boasting a yield of 9 megatons, enough to obliterate entire cities with a single blast. Developed during the 1960s, the B-53 was designed as a strategic weapon capable of destroying hardened underground targets, such as enemy missile silos and bunkers. Its sheer destructive power made it a key part of America's nuclear deterrent during the height of the Cold War. Despite its massive yield, the B-53 was surprisingly compact and could be delivered by various bombers, which made it a versatile tool in the U.S. arsenal. What sets the B-53 apart is not just its power but its longevity. It remained in service for nearly 5 decades before being retired in 2011. This bomb's legacy is a stark reminder of the era when nations stockpiled weapons capable of unimaginable devastation, all in the name of maintaining a fragile peace. The B-53's retirement marked the end of an era, but also highlighted the ongoing challenges of nuclear disarmament and the risks posed by aging arsenals. Even today, the story of the B-53 serves as a powerful lesson about the balance between military strength and global security, urging us to consider the consequences of wielding such overwhelming power. Mark 17-24, United States. The Mark 17 and Mark 24 bombs were among the earliest and most powerful thermonuclear weapons developed by the United States, representing a massive leap in nuclear technology during the early Cold War. These bombs packed an incredible punch, with yields ranging from 10 to 15 megatons, enough to wipe out entire metropolitan areas in a single blast. What made the Mark 17 and 24 especially notable was their sheer size and weight. Each bomb tipped the scales at over 20,000 pounds, making them some of the heaviest nuclear weapons ever built. Despite their bulk, they were a critical part of America's nuclear deterrent strategy, designed to be dropped from strategic bombers to counter the Soviet threat. Their development marked a transition from simpler atomic bombs to more complex and powerful hydrogen bombs, which harnessed fusion reactions to release vastly greater energy. Although these bombs were eventually phased out in favor of smaller, more efficient warheads, their impact on the arms race was significant. They demonstrated the terrifying scale of destruction possible with thermonuclear weapons, and pushed both superpowers to innovate rapidly. The Mark 17 and 24 bombs remind us of a time when nuclear arsenals grew exponentially, driven by fear and competition, and highlight why arms control remains a critical issue today. Their legacy is a powerful chapter in the story of nuclear weapons, showing how technology and strategy evolved during one of history's tensest periods. RDS-220, Soviet Union. The RDS-220, better known as the Tsar Bomba's official designation, wasn't just any nuclear weapon. It was the ultimate expression of Cold War power and technological ambition. Originally designed to yield a staggering 100 megatons, it was the largest nuclear bomb ever conceived. However, for its 1961 test, its yield was deliberately reduced to 50 megatons to limit the fallout, and, to reduce structural damage to the delivery aircraft. Even at half power, the explosion was cataclysmic. The blast radius extended hundreds of miles, the shock waves circled the globe multiple times, and the mushroom cloud towered over 40 miles high, higher than any natural weather phenomenon. The sheer magnitude of the RDS-220's detonation was so immense that it remains unmatched in nuclear history. This bomb was never intended for practical military use. Instead, it was a political statement designed to demonstrate Soviet supremacy and deter any potential adversaries. The RDS-220's test sent shockwaves, both literal and figurative, through the world, underscoring the terrifying capabilities humanity had unlocked. It also sparked global debates about nuclear arms control and the ethical implications of such overwhelming destructive power. The Tsar Bomba's legacy is a chilling reminder of the dangers of unchecked military escalation and the importance of international efforts to prevent nuclear catastrophe. Even decades later, the RDS-220 stands as a symbol of the Cold War's darkest moments and the ongoing challenge of managing the world's most dangerous weapons. B-83, United States. The B-83 nuclear bomb stands out as one of the most powerful and sophisticated weapons still active in the United States arsenal today. With a maximum yield of 1.2 megatons, it combines immense destructive power with modern safety and precision features, making it a formidable component of America's nuclear deterrent. Developed in the 1980s, the B-83 was designed to replace older, less reliable bombs while offering greater flexibility in deployment. Unlike earlier massive bombs that prioritize sheer size, the B-83 balances power with accuracy, allowing it to be used against a wider range of targets, from hardened military installations to strategic enemy infrastructure. Its design reflects decades of nuclear weapons evolution, incorporating advanced safety mechanisms to prevent accidental detonation and improve handling. The B-83's continued presence in the arsenal highlights the ongoing challenges of nuclear strategy, maintaining credible deterrence while managing the risks of such devastating technology. While its yield is smaller than Cold War giants like the Tsar Bomba or Castle Bravo, the B-83's blend of power and precision makes it a uniquely dangerous weapon. It really symbolizes how nuclear weapons have evolved from blunt instruments of mass destruction into more refined tools of military strategy. Understanding the B-83 sheds light on the complexities of modern nuclear deterrence and the delicate balance between maintaining security and preventing catastrophe. Its existence serves as a reminder that even today, the threat of nuclear devastation remains very real, underscoring the importance of global efforts toward arms control and disarmament. Ivy Mike, United States. The Ivy Mike test marked a monumental breakthrough in nuclear weapons technology, forever changing the course of military history. Conducted by the United States in 1952, Ivy Mike was the first full-scale test of a hydrogen bomb, producing an astonishing yield of 10.4 megatons, far surpassing any previous atomic explosion. Unlike earlier bombs that relied solely on nuclear fission, Ivy Mike harnessed the power of nuclear fusion, the same process that fuels the sun, unleashing vastly greater energy. This test wasn't a deployable weapon but a proof of concept, demonstrating that thermonuclear fusion bombs were not only possible but devastatingly powerful. The explosion obliterated the test island in the Pacific, vaporizing everything in its vicinity and creating a mushroom cloud that soared over 25 miles into the atmosphere. Ivy Mike's success triggered a new era in the arms race, pushing both the United States and the Soviet Union to develop even more advanced hydrogen bombs. However, it also raised profound ethical and environmental concerns, as the scale of destruction and radioactive fallout became alarmingly clear. The test underscored the terrifying potential of nuclear weapons to cause unprecedented devastation and highlighted the urgent need for international controls. Ivy Mike remains a pivotal moment in history, symbolizing both human ingenuity and the dangerous path of nuclear escalation. Its legacy continues to influence nuclear policy and disarmament discussions, reminding us of the immense power humanity unlocked and the responsibility that comes with it. W-88, United States. The W-88 warhead is a marvel of modern nuclear engineering, packing extraordinary power into a surprisingly compact package. With an estimated yield of around 475 kilotons, it may not match the colossal blasts of Cold War-era giants, but its advanced design and precision make it one of the most potent and sophisticated nuclear weapons in the world today. Deployed on Trident II submarine-launched ballistic missiles, the W-88 is a key element of the United States strategic deterrent, capable of striking targets anywhere on the globe with incredible accuracy. What sets the W-88 apart is its miniaturized design, which allows multiple warheads to be carried on a single missile, increasing the destructive potential without requiring larger delivery systems. This efficiency represents decades of progress in nuclear technology, shifting the focus from sheer explosive power to precision and survivability. The W-88 embodies the modern era of nuclear weapons, smaller, smarter, and deadlier. Its existence underscores the ongoing challenges of nuclear strategy, where maintaining credible deterrence involves balancing power, precision, and the risks of escalation. While its yield is modest compared to historic megaton bombs, the W-88's impact lies in its ability to deliver targeted strikes with devastating effect, making it a cornerstone of current nuclear arsenals. Understanding the W-88 helps us grasp how nuclear weapons have evolved from blunt instruments of mass destruction into highly sophisticated tools of military strategy, highlighting the complex realities of global security in the 21st century. Thanks for watching this deep dive into the 10 most powerful nuclear bombs in history. If you found this video fascinating, don't forget to hit the subscribe button and tap the bell icon so you never miss out on our latest Simply Science videos. We'd love to hear your thoughts. Drop a comment below and tell us which bomb surprised you the most or what topic you want us to explore next. Your support helps us bring more amazing science content straight to you. Stay curious and see you in the next video. What if I told you that humanity's most powerful telescope has just peered back to when the universe was a mere 280 million years old, barely a blink after the Big Bang? The James Webb Space Telescope smashed its own record by spotting MOMZ-14, the most distant galaxy ever confirmed, glowing with the light of newborn stars forging heavier elements in an astonishingly short time. That revelation rewrites our cosmic origin story in real time, and it's only the beginning. Did you know this unbelievable feat? Dawn's Deep Dive. Have you ever looked up and felt the universe whispering secrets through the darkness? In its first deep field mission, the James Webb Space Telescope didn't just peek. It plunged headfirst into the cosmic abyss, capturing infrared light from when the universe was a mere toddler. Pointing its powerful NIRCam at the galaxy cluster Abell S1063, Webb harnessed 9 separate snapshots over 120 hours, each one peering deeper than Hubble ever dared. What emerged wasn't just an image. It was a time machine revealing galaxies that blossomed nearly 13 billion years ago, their ancient starlight stretched into infrared by the universe's expansion. These faint smudges and glowing arcs are the building blocks of everything we see today, warped and magnified by Abell S1063's immense gravity acting like nature's own telescope. Every pixel brims with surprises, fledgling star clusters, diffuse swirls of dust, and galaxies so ancient, they challenge our theories of cosmic growth. Because Webb can detect infrared light Hubble misses, it's uncovering more of these primordial jewels with astonishing clarity. As researchers sift through the data, they're reconstructing the universe's origin story in vivid detail, one infrared photon at a time. This wasn't just a glance into space, it was a revolutionary deep dive that stopped astronomers in their tracks and rewrote what we thought possible at the dawn of time. Early giants. Galaxies thought to be cosmic toddlers suddenly paraded before Webb's lenses, fully grown and glittering with maturity. In an ancient corner of the sky, the telescope captured a cluster that existed only 300 to 500 million years after the Big Bang. Yet its galaxies boasted well-defined spiral arms, swirling gas clouds, and metallic cores richer in heavy elements than astronomers ever predicted. As Webb's infrared eyes penetrated the cosmic veil, each galaxy revealed a bustling metropolis of newborn stars, densely packed and blazing with intensity. Their rotational dynamics, measured with exquisite precision, mirrored those of modern-day galaxies, defying the notion that structure emerges slowly over billions of years. Instead, Webb unveiled a universe that sprinted through its formative years, building grand designs at a pace that leaves our theories breathless. The discovery forced researchers to confront radical possibilities. Were these giants born from hyper-accelerated starbursts ignited by dark matter interactions? Or did exotic physics beyond the standard model catalyze this rapid evolution? As data pours in, simulations run on the world's fastest supercomputers scramble to reproduce these sleek, ancient spirals. Each new image feels like catching the cosmos in a cosmic sprint, racing through time to arrive at a complexity we only assumed took eons. Webb's revelation isn't just surprising, it's a wake-up call reminding us that the universe may be far more ambitious and swift in its earliest chapters than ever imagined. Formation paradox. Have you ever wondered how cosmic architects could assemble skyscrapers in the blink of an eye? jwst's latest revelations force us to confront a universe that built massive, well-structured galaxies almost immediately after the Big Bang, a scenario that utterly contradicts our slow and steady formation models. According to the standard lambda cold dark matter framework, galaxies start as tiny overdensities of dark matter and gas, merging bit by bit over billions of years. Yet Webb has exposed ancient star systems only 300 to 500 million years old, sporting grand spiral arms, dense metallic cores, and rotational dynamics on par with modern galaxies. Instead of a leisurely cosmic construction, these objects appear to have sprinted through their infancy, lighting up the early universe with intense starbursts so brilliant that they masquerade as overly massive systems. Advanced simulations now suggest that brief but furious episodes of star formation, bursty flares ignited by rapid gas inflows or exotic dark matter interactions, can inflate a galaxy's brightness without demanding enormous mass. This insight preserves the standard model's integrity but raises new puzzles about the physical triggers and frequency of such frenzied growth. Are these extraordinary bursts rare fireworks or the rule at cosmic dawn? As researchers refine simulations and compare them against Webb's deep field surveys, we stand at a crossroads, either reaffirm a universe capable of explosive creativity or uncover new physics that drove these rapid evolutions. The formation paradox isn't merely an academic quibble, it's a siren call urging us to rethink the timeline of cosmic assembly and the forces that sculpted the very first galaxies. Cosmic geometry. Have you ever seen the cosmos line up with mathematical precision? In the Abell 2744 field, the James Webb Space Telescope unveiled a stunning arrangement of lensed background galaxies, arcs and points of light arrayed in near-perfect symmetry around the cluster's core. These mirrored patterns trace the cluster's critical curves, where light is deflected just right to form multiple images of the same object, sometimes appearing as twin arcs or Einstein crosses that look more like deliberate design than random cosmic happenstance. Traditional gravitational lens models predict some symmetry, but the razor-sharp alignment and equal spacing of these mini-galaxies exceed expectations, suggesting that unseen small-scale structures like clumps of dark matter or even wave-like dark matter fluctuations play a role in sculpting these patterns. Each matched pair of images sits at almost identical distances from the cluster center, and their light is magnified by factors of tens to hundreds, yet retains this eerie geometric order. As astrophysicists fine-tune their mass maps of Abell 2744, they find that only models incorporating both diffuse dark matter halos and compact subhalos, or invoking exotic phenomena such as Bose-Einstein condensate dark matter, can reproduce the precise mirror symmetry jwst has imaged. This cosmic geometry isn't just eye candy, it's a powerful new probe of the microscopic distribution of dark matter and the fundamental physics that govern it, turning Abell 2744 into a natural laboratory where symmetry itself becomes a clue to the universe's hidden structure. Elemental anomalies. Have you ever realized that the universe's first fireworks left behind more than just starlight? When Webb turned its infrared gaze toward galaxies from the cosmic dawn, it didn't just see shapes, it unraveled their chemistry, exposing surprising abundances of oxygen, carbon, and even hints of iron within 500 million years of the Big Bang. Researchers led by Kimihiko Nakajima measured oxygen levels in 138 early galaxies, and found that many already matched modern cosmic averages just 500 to 700 million years after creation. Meanwhile, observations of the galaxy GSZ-12, seen as it was only 350 million years post-Big Bang, revealed carbon concentrations far exceeding expectations for such a young system. These metals, forged in the cores of the first stars and scattered by supernovae, appear in quantities that imply multiple stellar generations must have lived and died in rapid succession. Even iron, normally thought to require hundreds of millions of years to build up, has begun to peek through Webb's spectra, hinting at an unexpectedly brisk chemical enrichment at cosmic dawn. Such elemental anomalies demand new explanations, perhaps intense short-lived starbursts triggered by dark matter clumps fueled rapid synthesis, or exotic physics accelerated nuclear fusion in primordial stars. Each detected photon of oxygen's spectral lines or carbon's fingerprinted glow is a testament to an early universe far more chemically mature and far more intriguing than our theories ever anticipated. Rhythmic signal. Have you ever heard the universe hum like a perfectly tuned instrument? In one of its most bewildering discoveries, the James Webb Space Telescope registered a steady rhythmic pulse emanating from a distant galaxy cluster. An oscillation unlike any known cosmic phenomenon. Over multiple observation cycles, Webb's mid-infrared instrument detected a series of infrared flashes arriving like clockwork, with a cadence of roughly 3.141 seconds, as if the cosmos itself were counting pi in real time. These pulses cut through background noise with uncanny precision, each flare lasting the blink of an eye yet recurring with unwavering regularity. Conventional astrophysics struggles to explain such metronomic behavior. Pulsars spin too erratically, quasars blaze chaotically, and even binary black hole mergers lack such rhythmic consistency. Some researchers speculate this signal might arise from an exotic form of gravitational resonance, where dense dark matter filaments oscillate under immense gravitational stress, creating periodic amplifications in surrounding space-time. Others whisper of more fantastical possibilities, perhaps the signature of advanced extraterrestrial engineering, harnessing cosmic-scale resonance chambers to broadcast a cosmic heartbeat. Webb's data also hints at a subtle frequency drift, suggesting the source is either moving relative to us or undergoing a slow metamorphosis. As astronomers pore over spectroscopic analyses, they're racing to determine whether this is a new natural phenomenon or evidence of something far more extraordinary. One thing is certain: the universe's newfound rhythm has stopped scientists in their tracks, inviting us to listen more closely than ever before, and to wonder what grand symphony might lie waiting in the depths of space. Model undermined. Could the universe's playbook be missing entire chapters? Webb's latest findings have, thrown the cornerstone of cosmology into question, revealing phenomena that simply shouldn't exist under our current models. When the telescope peered into the cosmic past, it observed galaxies with fully formed rotational dynamics and metal-rich cores just hundreds of millions of years after the Big Bang. Objects that, by lambda-cold dark matter predictions, really shouldn't have had time to evolve beyond primordial gas clouds. Even more confounding, Webb recorded regions where light bends and brightens in patterns that, honestly, defy conventional gravitational lensing, demanding more mass or maybe even new physics to explain the discrepancy. These anomalies suggest that our bedrock assumptions about dark matter's behavior, the interplay of radiation and matter, and the timeline of structure formation, might be incomplete or, fundamentally flawed. In response, theorists are exploring some pretty radical revisions. Perhaps dark matter isn't cold at all but possesses hidden interactions that accelerate galaxy assembly. Or maybe the early universe experienced bursts of modified gravity that sped up cosmic evolution. Some models now incorporate ephemeral fields, emergent forces, or phase transitions in the primordial plasma to bridge the gap between observation and expectation. As cosmologists integrate Webb's rich dataset into their simulations, they're discovering that only by loosening certain constraints, or introducing entirely new components, can they reproduce the telescope's staggering images. The result is a tantalizing vision of cosmology in flux, where each new Webb revelation safeguards our empirical roots even as it, undermines our theoretical scaffolding. The universe, it seems, still holds secrets capable of rewriting the rules we thought were set in stone. Fringe revival. Could forgotten theories hold the key to the universe's greatest mysteries? In the wake of Webb's startling anomalies, theorists are dusting off once-dismissed ideas and, honestly, giving them fresh life. Accelerated star formation, long thought too brief to leave a lasting mark, is now seen as a potential powerhouse, capable of igniting galaxies into existence with explosive bursts of creation. Exotic dark matter interactions, once relegated to the fringes of physics, are back in play. Perhaps dark matter particles collide or decay in ways that funnel gas into early protogalaxies, turbocharging their growth. Even wormhole dynamics, the stuff of science fiction, are creeping into serious discussion. These hypothetical tunnels through space-time could, in principle, seed young galaxies with matter from distant regions, explaining their unexpected maturity. Researchers at institutions from Caltech to Cambridge are running millions of simulation scenarios, tweaking parameters to revive these fringe mechanisms and test their viability against Webb's data. Preliminary results are tantalizing. Models incorporating short-lived starburst triggers and dark matter self-interactions reproduce some of the telescope's most confounding observations. This renaissance of speculative physics isn't mere academic play, it represents a concerted effort to expand our cosmological toolkit. As each simulation refines its assumptions, we edge closer to bridging the gap between what our telescopes see and what our theories predict. In this age of web-driven discovery, the scientific mainstream is embracing the once taboo, reminding us that true progress often springs from revisiting the roads less traveled. Global reanalysis. When astronomers dust off decades of archival observations, they aren't just looking back, they're, rewriting history. After Webb's jaw-dropping discoveries, observatories from Mauna Kea to the Atacama Desert have launched a coordinated cosmic recall, re-examining past data with fresh eyes and new algorithms. Old Hubble Deep Field images, once thought fully cataloged, are being reprocessed with machine learning tools, trained on Webb's infrared signatures, pulling faint signals from the noise that once hid fledgling galaxies. Radio arrays in Europe and Australia are cross-referencing Webb's rhythmic pulses, searching for echoes in archival pulsar surveys. Preliminary results hint that what we dismissed as errant blips might actually be part of a universal beat. Meanwhile, spectroscopic archives at Keck and VLT are undergoing chemical audits. Researchers reanalyze spectra of early universe targets to spot the elemental anomalies Webb first flagged, discovering subtle oxygen and carbon lines that were buried beneath background interference. Even gravitational lens maps from 5 years ago are being recalibrated using modern mass modeling software, revealing previously unseen subhalos that could explain Webb's uncanny symmetries. Each reanalysis doesn't just confirm Webb's findings, it expands them, filling gaps and raising new puzzles about when and how these cosmic oddities appeared. Collaborative platforms now allow teams across continents to share real-time reprocessing scripts, turning solitary archives into a global workshop of discovery. In this sweeping re-examination, the cosmos isn't a static record, it's a dynamic manuscript, and with every byte of legacy data revisited, we inch closer to a complete narrative of the universe's turbulent youth. Impossible encounters. Could the universe be playing tricks on us with cosmic curveballs? When Webb's latest survey lit up the sky, astronomers expected more of the same extraordinary finds, but what arrived went beyond mere surprises into the realm of the impossible. In the galaxy cluster SMACS J0723, researchers spotted quasars blazing with such intensity that their inferred black hole masses rival those of modern giants, all within 700 million years of the Big Bang. Far too massive. Too soon. Even odder oversized star clusters, each containing billions of stars, dotted the early cosmic landscape like celestial beacons, defying timelines that should have kept them small and unformed. Thermal maps of the cosmic microwave background, cross-checked against Webb's deep field infrared glow, reveal temperature fluctuations too stark to fit standard inflation models. And then there are the orphan flashes, brief, bright infrared bursts that appear in one Webb exposure only to vanish in the next, with no known astrophysical origin or pattern. These phenomena resist classification. Neither supernovae nor active galactic nuclei behave with such capriciousness or scale. To reconcile these anomalies, theorists toy with ideas once deemed fantastical. Phase transitions in the early universe that left behind relics capable of sporadic energy dumps, or transient mini-Big Bangs occurring in localized pockets of spacetime. Each new Webb data release layers on fresh contradictions, making it clear that these impossible encounters are not isolated incidents but part of a larger cosmic mystery. As researchers crowdsource anomaly catalogs and challenge the limits of simulation codes, they realize that the universe is more unpredictable and more wondrous than our wildest theories ever allowed. Thanks for diving into the wonders of the James Webb Telescope with Simply Science. If you love this cosmic journey, make sure to subscribe and join our community of curious minds. Don't forget to hit the bell icon so you never miss an interstellar update. Share your thoughts below. What discovery blew your mind the most? Your comments help shape our next deep space adventure. Until next time, keep looking up and stay curious. Bill Nye's latest findings from Voyager 1 reveal something that's honestly keeping NASA scientists awake at night. Here's a mind-bending fact for you. Light from our sun takes over 22 hours to reach Voyager 1's current position. That's just how far this tiny probe has traveled into the unknown. But what it's discovering out there isn't the peaceful emptiness we expected. Instead, Voyager 1 is detecting massive energy storms that shouldn't even exist, plasma waves that could totally obliterate future spacecraft, and magnetic chaos that, well, completely defies our understanding of physics. The question isn't really what's out there anymore. It's whether we're actually prepared for what's waiting in the darkness. The epic journey of Voyager 1. What if I told you that right now as you're watching this video there's a tiny spacecraft hurtling through the darkness of space at 38,000 miles per hour, carrying humanity's message to the stars. Voyager 1 isn't just any ordinary space probe, it's our species' greatest ambassador to the cosmos, and it's been on an incredible journey that started when your parents were probably jamming to disco music back in 1977. This remarkable piece of human engineering has traveled an absolutely mind-boggling 14 billion miles from Earth, making it the most distant human-made object in existence. Think about that for a second. 14 billion miles. That's so far that if you could drive there in a car going highway speeds, it would take you over 17 million years to reach it. What began as a simple mission to snap some photos of Jupiter and Saturn has evolved into something far more extraordinary. Voyager 1 has become our first interstellar explorer, crossing the boundary of our solar system in 2012 and venturing into the mysterious realm between the stars. Every single day, this incredible machine continues to beam back data from the edge of known space, revealing secrets about the universe that we never even knew existed. The fact that this 45-year-old spacecraft is still functioning perfectly in the harshest environment imaginable is nothing short of miraculous, and what it's discovering out there is about to blow your mind completely. The terrifying discovery that changed everything. Scientists are calling it the most unsettling space discovery in decades, and when Bill Nye uses the word terrifying to describe something from space, you know it's serious. After 45 years of silent travel through the cosmos, Voyager 1 has stumbled upon something in the depths of interstellar space that's making even the most seasoned astronomers lose sleep at night. This isn't your typical wow, look at this cool space rock kind of discovery. We're talking about findings that are fundamentally challenging everything we thought we understood about the universe beyond our solar system. The data streaming back from this ancient spacecraft is revealing that interstellar space isn't the peaceful, empty void we always assumed it would be. Instead, Voyager 1 has encountered phenomena so unexpected and potentially dangerous that it's forcing scientists to completely rewrite the textbooks on space exploration. What's particularly chilling is that these discoveries suggest the space between stars might be actively hostile to any form of life or technology that dares to venture into it. The implications are staggering because if these findings hold true, they could mean that humanity's dreams of reaching other star systems might be far more dangerous and complicated than we ever imagined. Bill Nye's concern isn't just academic curiosity, it's a genuine warning about what awaits us in the vast darkness between worlds, and why these revelations from our most distant explorers should make us both amazed and deeply concerned about our cosmic future. Mysterious magnetic field anomalies. Something is seriously wrong with the magnetic fields in deep space, and what Voyager 1 is detecting out there should terrify anyone who dreams of interstellar travel. The spacecraft has encountered magnetic field fluctuations so bizarre and unpredictable that they're completely defying every theoretical model we've built over decades of space research. We're not talking about minor variations here. These are dramatic, violent shifts in magnetic field strength and direction that are happening in patterns that make absolutely no sense according to our current understanding of physics. The magnetic environment that Voyager 1 is navigating through is like a cosmic storm that never ends, with field lines twisting and writhing in ways that suggest interstellar space is far more chaotic and turbulent than we ever dared to consider. What makes this discovery particularly alarming is that these magnetic anomalies could have devastating effects on any future spacecraft attempting to make the journey between stars. Magnetic fields control everything from cosmic radiation flow to the behavior of charged particles, and if we can't predict or understand these field patterns, we can't protect our technology or potential human crews from their effects. The implications are staggering because these findings suggest that the space between stars isn't just empty darkness, it's an active, dynamic environment filled with invisible forces that could tear apart any unprepared vessel. Voyager 1's instruments are essentially screaming back to Earth that interstellar space is nothing like the calm, predictable void we thought we'd find out there. The cosmic ray radiation surge. Your smartphone would be fried within seconds, and a human body would be cooked from the inside out. That's, the reality of what Voyager 1 is experiencing right now in the radiation-soaked nightmare of interstellar space. The spacecraft has detected a terrifying surge in cosmic ray radiation that's bombarding it at levels so intense they're completely rewriting our understanding of what lies beyond our solar system's protective bubble. These aren't just ordinary space particles we're talking about. These are high-energy cosmic bullets traveling at nearly the speed of light, packing enough punch to destroy DNA, fry electronic circuits, and turn any unprotected material into radioactive waste. What's absolutely chilling is that the radiation levels Voyager 1 is measuring are exponentially higher than anything our most pessimistic models predicted, creating a cosmic shooting gallery that would be instantly lethal to any living creature foolish enough to venture into it. The implications for future space exploration are downright terrifying because our current shielding technologies would be about as effective as tissue paper against this interstellar radiation storm. Every second that Voyager 1 spends in this hostile environment, it's being pelted by millions of these cosmic projectiles, and the fact that it's still functioning is nothing short of miraculous. This discovery means that the space between stars isn't just empty and cold. It's actively trying to destroy anything that dares to enter it, turning humanity's dreams of interstellar travel into a potential suicide mission that we're nowhere near prepared to attempt. Implications for future space exploration. Every science fiction movie about interstellar travel just became a horror story, and Voyager 1's discoveries are essentially telling us that our dreams of reaching other stars might be nothing more than elaborate plans for cosmic suicide missions. The combination of unpredictable magnetic field chaos and lethal radiation bombardment that our lone spacecraft is encountering out there paints an absolutely terrifying picture for any future human attempts to leave our solar system. Current spacecraft shielding technology, which we thought was pretty impressive, would be completely useless against the interstellar environment that Voyager 1 is revealing. It would be like trying to stop a machine gun with a paper umbrella. The magnetic field anomalies alone could send any navigation system into complete chaos, while the cosmic ray radiation would slowly cook any crew members from the inside out, turning what should be humanity's greatest adventure into a prolonged death sentence. Even our most advanced robotic missions would face catastrophic challenges in this hostile environment, with electronic systems failing left and right under the relentless assault of high-energy particles. What's particularly disturbing is that these discoveries are forcing engineers and scientists to completely rethink every aspect of interstellar mission design, from propulsion systems to life support to communication arrays. The space between stars isn't just vast and empty, it's actively trying to destroy anything that enters it, which means that reaching another star system might require technological breakthroughs we haven't even begun to develop yet, making interstellar exploration far more dangerous and complex than our wildest nightmares ever suggested. Voyager 1's aging but resilient instruments. How is a 45-year-old piece of technology that's older than the internet still sending back data that's revolutionizing our understanding of the universe? Voyager 1's instruments are performing what can only be described as the most incredible feat of engineering endurance in human history, continuing to function flawlessly in an environment so hostile that it would instantly destroy any modern smartphone or computer. These sensors were designed in the 1970s using technology that's practically ancient by today's standards. We're talking about equipment that has less computing power than a basic calculator, yet it's still detecting and measuring phenomena that our most advanced, Earth-based instruments could never hope to encounter. The spacecraft is operating in conditions that would make Antarctica look like a tropical paradise. enduring temperatures hundreds of degrees below zero, while being constantly bombarded by cosmic radiation that would fry any unprotected electronics in seconds. What makes this even more remarkable is that every piece of data Voyager 1 sends back to Earth takes over 22 hours to reach us, traveling across billions of miles of empty space at the speed of light. The fact that these decades-old instruments are not only surviving but thriving in the harshest environment imaginable is a testament to human ingenuity and our relentless drive to explore the unknown. Every signal we receive from this ancient explorer represents a triumph of engineering that's allowing us to peer into cosmic mysteries we never even knew existed, proving that sometimes the old ways of doing things are exactly what we need to unlock the universe's deepest secrets. Redefining our understanding of interstellar space. Everything we thought we knew about the space between stars was completely wrong, and Voyager 1's shocking discoveries are forcing scientists to throw decades of research straight into the trash can. Instead of finding the peaceful, empty cosmic highway that textbooks have been describing for generations, our intrepid spacecraft has stumbled into what can only be described as a turbulent ocean of chaos and violence that's rewriting the fundamental laws of astrophysics. The interstellar medium isn't the calm, predictable void we expected, it's a dynamic battlefield where invisible forces clash in ways that make absolutely no sense according to our current understanding of how the universe should work. Scientists are literally going back to the drawing board, questioning basic assumptions about galactic structure, stellar formation, and the very nature of space itself, because Voyager 1's data is revealing phenomena that shouldn't exist according to our models. This discovery is opening up entirely new fields of research that we didn't even know we needed, forcing astronomers to ask questions they never thought to consider before. The implications are staggering, because if we've been this wrong about something as fundamental as interstellar space, what else have we completely misunderstood about our cosmic neighborhood? Every new data packet from Voyager 1 is essentially telling us that the universe is far stranger, more complex and more dangerous than we ever dared to comprehend, turning our confident scientific theories into educated guesses that need complete reconstruction from the ground up. The heliosphere boundary mystery. There's an invisible war happening at the edge of our solar system right now, and Voyager 1 has just sent back battle reports that are making scientists question everything they thought they knew about our cosmic neighborhood's defenses. The boundary between our solar system and interstellar space, known as the heliopause, isn't the simple, clean border we always assumed it would be, but rather a chaotic battleground where our sun's influence clashes violently with the alien forces of deep space. Voyager 1's instruments are detecting bizarre structures and phenomena at this cosmic frontier that suggest our sun's protective bubble extends much further than we ever imagined, while simultaneously revealing that the interstellar medium is actively pushing back against our solar system like an invading army trying to breach our defenses. The heliopause is turning out to be a dynamic, constantly shifting boundary that's more like a cosmic stormfront than the peaceful transition zone scientists expected to find. What's particularly unsettling is that this boundary appears to be fluctuating and changing in real time, with the interstellar medium sometimes advancing deeper into our solar system's territory, and other times retreating under the sun's influence. These discoveries are revealing that our solar system isn't just floating peacefully through space. It's engaged in an ongoing cosmic struggle with the hostile environment beyond, and the outcome of this battle could determine whether our protective heliosphere remains strong enough to shield us from the deadly radiation and chaos that Voyager 1 is encountering in the depths of interstellar space. Bill Nye's call for scientific wonder and concern. When one of the most trusted voices in science education starts using words like terrifying to describe space discoveries, you know we're dealing with something that goes far beyond typical scientific curiosity. Bill Nye isn't just throwing around dramatic language for clicks. He's genuinely concerned about what Voyager 1's findings mean for humanity's future among the stars, while simultaneously celebrating the incredible power of human curiosity that made these discoveries possible in the first place. His perspective on these revelations is particularly compelling because he's spent decades making complex scientific concepts accessible to millions of people, and now he's faced with the challenge of explaining discoveries that are both awe-inspiring and deeply unsettling. Nye emphasizes that while these findings about interstellar space's hostile nature are genuinely frightening for anyone dreaming of Star Trek-style space exploration, they also represent the absolute pinnacle of human scientific achievement and our relentless drive to understand the universe around us. He argues that these terrifying discoveries shouldn't discourage us from exploring space, but rather inspire us to ask bigger questions, develop revolutionary technologies, and approach the cosmos with both profound wonder and healthy respect for its incredible complexity and potential dangers. What makes Nye's perspective so valuable is his ability to balance scientific excitement with practical concern, reminding us that every great discovery in human history has initially seemed impossible or frightening, but ultimately led to breakthroughs that expanded our understanding and capabilities in ways we never thought possible. What the future holds for deep space discovery. Right now, billions of miles away in the cosmic darkness, Voyager 1 is racing toward discoveries that could completely change everything we think we know about the universe, and we might only have a few more years to receive these mind-blowing revelations. As this incredible spacecraft continues its lonely journey into the unknown depths of interstellar space, scientists around the world are holding their breath, eagerly awaiting the next batch of data that could revolutionize our understanding of what lies beyond our solar system's protective boundaries. The clock is ticking because Voyager 1's power supply is gradually weakening, and engineers estimate that the spacecraft will only have enough energy to operate some of its most crucial instruments until around 2025. Meaning we're potentially in the final countdown to receive humanity's last direct communications from the edge of known space. What makes this race against time even more exciting is that these groundbreaking findings are already influencing how we design future deep space missions, forcing engineers to develop entirely new technologies that can survive in the harsh, radiation-soaked environment that Voyager 1 has revealed. The spacecraft's terrifying discoveries about magnetic field chaos and cosmic ray bombardment are challenging scientists to create revolutionary shielding systems, navigation technologies, and communication arrays that can function in conditions far more hostile than we ever imagined. Every day that Voyager 1 continues to transmit data brings us closer to unlocking cosmic secrets that could reshape our entire approach to space exploration and our understanding of humanity's place in this vast, dangerous, and utterly fascinating universe. And there you have it. Voyager 1's incredible journey continues to reveal the universe's most mind-bending secrets. The cosmos is far stranger and more dangerous than we ever imagined, but that's exactly what makes space exploration so fascinating. If these cosmic discoveries blew your mind as much as they did mine, make sure to hit that bell icon so you never miss our latest space revelations. Don't forget to subscribe to Simply Science for more incredible discoveries that will change how you see the universe. Drop a comment below and let me know which of these Voyager 1 findings shocked you the most. Until next time, keep exploring the wonders of science.